Before a car with an automatic transmission even begins to move, a silent and fluid-based device is already at work, shaping how power flows from the engine to the wheels. This component is called the torque converter, and without it, modern automatic transmissions simply could not function the way they do. It replaces the manual clutch, but its role goes far beyond simple engagement and disengagement. The torque converter is both a connector and a multiplier of power, operating through the principles of fluid dynamics rather than direct mechanical contact. At its most basic level, the torque converter is a hydrodynamic coupling. It allows the engine to keep running even when the vehicle is stationary, something a rigid mechanical connection would not permit. When the engine is idling and the car is stopped, the torque converter slips smoothly, preventing the engine from stalling while still remaining ready to transmit power the moment acceleration begins. Inside the torque converter housing are three main components: the pump or impeller, the turbine, and the stator. All of these parts are enclosed in a sealed casing filled with transmission fluid. The entire system relies on the controlled movement of this fluid to transfer energy. The pump is connected directly to the engine's crankshaft. Whenever the engine turns, the pump rotates with it, throwing transmission fluid outward due to centrifugal force. This fast-moving fluid is directed toward the turbine, which is connected to the transmission input shaft. As the fluid strikes the turbine blades, it causes the turbine to rotate, transmitting torque into the transmission and ultimately to the wheels. At this stage, the torque converter behaves like a simple fluid coupling, but its true advantage appears during acceleration from low speed. As fluid exits the turbine, it flows back toward the pump. If left uncontrolled, this returning fluid would oppose the pump's rotation, reducing efficiency. This is where the stator plays its critical role. The stator is positioned between the pump and the turbine and is mounted on a one-way clutch. Its job is to redirect the returning fluid so that it re-enters the pump in the direction of rotation, rather than against it. By doing this, the stator dramatically increases the force applied to the pump, effectively multiplying torque. This torque multiplication is most significant at low vehicle speeds, such as when starting from rest or accelerating under load. As the vehicle gains speed, the turbine begins to rotate closer to the speed of the pump. The difference in fluid flow decreases, and the stator's one-way clutch allows it to freewheel. At this point, torque multiplication fades, and the torque converter transitions into a more efficient fluid coupling mode. This automatic behavior requires no sensors or electronics. It is purely the result of fluid flow and mechanical design. One drawback of early torque converters was efficiency loss at cruising speeds. Because fluid coupling always involves some slip, energy is lost as heat. To solve this, modern automatic transmissions use a lockup clutch inside the torque converter. At steady speeds, this clutch engages, creating a direct mechanical connection between the engine and the transmission. This eliminates slip, improves fuel efficiency, and reduces heat generation. The torque converter also plays a key role in driving comfort. Because power is transmitted through fluid, sudden changes in engine speed or load are smoothed out. This reduces shock to the drivetrain and allows for seamless starts and gear changes. It is one of the main reasons automatic transmissions feel smoother than manual ones, especially in stop-and-go traffic. From a mechanical protection standpoint, the torque converter acts as a buffer. It absorbs vibrations, dampens torque spikes, and reduces stress on gears and shafts. This contributes significantly to the longevity of automatic transmissions, especially in heavy vehicles or urban driving conditions. Despite its complexity, the torque converter operates continuously and automatically, without direct input from the driver. It adapts instantly to engine speed, throttle input, and load conditions. Whether the car is creeping forward in traffic, accelerating hard onto a highway, or cruising at constant speed, the torque converter is constantly adjusting how power is transmitted. In summary, the torque converter is far more than a replacement for a clutch. It is a fluid-based power management device that allows automatic transmissions to function smoothly, efficiently, and reliably. By combining torque transmission, torque multiplication, vibration damping, and adaptive behavior into a single unit, it transforms raw engine output into controlled, usable motion. Without the torque converter, automatic transmissions would lose their defining characteristics: smooth starts, effortless driving, and intelligent power delivery. Hidden inside the bell housing, working silently in oil and steel, the torque converter is one of the most elegant examples of fluid mechanics applied to real-world engineering.